Okie dokie. So for this problem, just looking at it, it's a lot to digest. And this is not 103, it's 10 to the third power. Okay. So just looking at it, I'm thinking that the way that we can solve it would first 10% of the heat. Okay, I got an idea. So it's going to be 1.6 times, yeah, it must absorb 1.6 times 10 to the third kilojoules, and if only 10% of the heat. So I'm going to divide it by 0.1. That's going to give me a bigger number because that means that I'm going to need even more heat if only 10% of the heat is produced. So from here, with this number, I can use the thermochemical equation and use stoichiometry so I can get the mass of CO2. So what I'm going to do is I'm going to convert this amount, kilojoules, using the conversion factor of 3 moles of CO2 will give me this much heat, and then CO2 has a molar mass of 44 because carbon has a molar mass of 12, oxygen has a molar mass of 16. 16 times 2 is 36. You add it together, and you get 44. So I'll go ahead and start the problem. So this is the first conversion factor, and I get it from the equation that we're given. Here, looking at it, so just digesting this information, it says that 3 moles of CO2 will give us this amount of heat, and that's essentially a ratio. Yep, basically a ratio, and that's my conversion factor that I use down here. Now I'm going to use another conversion factor, that being 44 grams per 1 mole of CO2. And this will give me 1,033 grams of CO2. Let me just cancel out the units. Yep, everything checks out. So you're gonna get 1,033 grams of CO2, which is emitted into the atmosphere during the grilling of the pork roast. And the textbook in the back, I think, has the answer 1 kilogram. I think. Yeah, almost equivalent. Yeah, so thank you for watching. I hope this helped you out with your homework. And once again, thank you for watching.